Okay, so this is my second class and overall 4 class. So in my first class, I mainly discuss about why Olympiad is important for a school student and uh, how a student can study, what are the syllabus, and I think I have touched 2-3 topics from here and there just to know each other, like if I remember correctly, then I have solved 3-4 problems from quadratic, or you can say polynomials, and also from discussing basics thing in number 3, like uh, how many primes are there, is there any pattern, and the characteristics of primes, like how primes behaves, uh, like in the first part we have seen that at the one time there are infinitely many primes, but at the same times there are like if we go, or you can say if we search primes in long terms, then it's very rare to find here and there, and there are some related conjectures. So in this class I will mainly discuss about few problems and related concepts, and so let us start with problems from sequence and series. So so series problems. I'm giving here few series, like so it goes up to infinite. Second series is say 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus and so on. Say third one is say 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus and so on. So on means is goes up to infinity, and so okay, so let us discuss few series and then again we will go ahead. So can you tell me what is the sum of uh, the sum of natural numbers? So if you calculate sum of first n natural numbers, and then the sum is n into n plus 1 by 2, and it's not difficult to prove, like, but I'm not proving. You have to just take summation, and again you have to, or you can just take first and last terms in pair, but anyway this is the sum. So if you take n very large, and then you can check that this series will blown up, like this will goes to infinity. So this is the very large uh, numbers, and in mathematics we will say like this sum is infinity, and the uh, so the correct way to write is like that, this goes to infinity. This is a very large number, or you can say that if you just take any numbers, like any, if you take any numbers, say m, and you will always find that after few terms this will go beyond that m. And what is the sum of this series? So here basically this is the geometric progressions, geometric series, like common ratio is 1 by 2, and the sum is equal to 2. So I'm writing here that like if and so on, and here if I am assuming that common ratio is less than 1, then sum of this series will be, so I am using this thing, but again you can easily prove. So you have to just take S here by multiplying RS, and this is the very easy proofs you can find in a school textbooks. So anyway, this is the sum of the series. So if you use this, but condition is that this R, which is called the common ratio, that must be lie between -1 to 1. So absolute value R is less than 1. So if you use this sum, then this will go up to 2. And of course, this value is limiting value of 2, of course, because you are working with the uh, here number of terms are infinite. So the correct way to say that this series goes up to 2, or in more precise term here you don't need to use that terms. So this is calling that limiting value of this series is 2. So although I am here writing equal to 2, but you have to assume that this is the limiting value, because whenever you find and whenever you calculate in the sum of infinite series, then you always think that that goes up to, or limiting value is this. Now question is, so here this is the interesting thing. In the first questions I have taken a series in such a way which is the sum of natural number which goes to infinite, and sum also is going to infinity. In the second series, again I am taking sum goes to infinity, but sum of this series is finite, which is equal to 2. Again in the last series of we are trying to find the sum of this series. So can you guess like what is the sum of this series? And this is a special name called harmonic series, but forget about name. So okay, any guess whether this series uh, goes to finite or infinite? And this is the, you can say, like, so let us check, like, okay, uh, so we will prove that sum of this series is again infinity, okay, and goes to infinity. So, and of course you can prove this series in, like, sum is infinity. So you can use calculus when, if you know the indefinite integration, but I am not going to use calculus. I will just use a simple method, even class 4 5th student can understand. So so the series is like that: 1 plus 1 by 2 plus 1 by 3, and so this is the, you can say that, sum of reciprocal of natural numbers, dot 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 dot. So what I will try to do, like, uh, I will prove by comparing this series with other series. So can you tell me, like, uh, so what I am going to do, like, first of all, I will take these two terms. Next term is here 1 by 5, 1 by 6, 1 by 7, 1 by 8, and so on, 1 by 9. So on. So here, first I have considered these two terms. Again, I will take four terms. So basically 1 by 3 plus 1 by 4, which is, you can say, greater than 1 by 4 plus 1 by 4, because 1 by 3 is greater than 1 by 4, and this part is basically equal to 1 by 2. Now I will consider this block, red block. So 1 by 5, 1 by 6, 1 by 7, 1 by 8, and this is the 1 by 8 is a smallest among these four. So of course I will compare with these four terms, and again this value is uh, 4 by 8, so equal to half. So now I will take, so here I have considered two terms, here four terms, here I am going to take 8 terms, okay, and so again 1 by 16 is a smallest among these 8 terms. So I will take 1 by 16 plus 1 by 16, so on, 1 by 16 8 times. So 8 by 16 means again 1 by 2. So this will, in this way I will continue. So first of all I have considered two terms, then the block of 4 terms, then block of 8 terms, again next will be the block of 16 terms, and in so on. If you just add things, so what you will find in this left hand side, that almost, you are in that way 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 and so on so on, and this value is basically greater than half plus half, because every block of containing say 2 to the power k, because this is 2, 4 and 8 and so on. So how many blocks will be there, because the numbers are infinite. Okay, so number of blocks means like here I have considered a block which contain 2 terms, here I have considered a block which contain 4 terms. So whether number of blocks will be finite or infinite, it's a point to think here. So if just think that, is it possible to cover all these terms by finite number of blocks? Answer is no. Why? Because in every blocks number of terms are finite, right? And even if you consider number of blocks finite, so this will not cover infinite terms. So since number of terms are infinite, so number of blocks will be infinite. Every blocks, you can consider just the numbers inside this block. So every blocks has some greater than half. So since there are infinite blocks, so if you add infinite half, so this will always be greater than infinite into half, and you can say ki infinity. And you just, if you add these first 2 terms, okay, so it's not going to matter. Also here also you can add half, 1 plus half. So of course if you add any finite terms into infinite, so it will remains infinite. So what you have like find here, that the sum of series is greater than a very large number, which is infinity. So that means the sum of this series will be infinite, because here we have shown in this way that that sum of this series is greater than infinite. That means this series also goes up to infinity. And here we use a comparison test, you can say comparison method. So yeah, so now come to this questions. Again you find that sum of this series, or this is called harmonic series, or you can say the reciprocal of the natural number, this is infinity. So my next question is the important questions ki, okay, say like if I from this series, third series, I am removing those terms which denominator containing 0. So for an examples, like I am taking this series 1 plus 1 by 2. First of all, I am writing 1 by 9, 1 by 10. I am writing this third one, but I will delete those terms, okay, which denominator has 0 at any places. So for an example, first of all, let me write this whole series 1 by 19 plus 1 by 20 and so on. Say 1 by 100, 1 by 101, 1 by 110 plus 1 by 111 and so on. So what I'm now doing, like say I am deleting those terms whose denominator contains 0 at any place. It's not, I am not saying ki uh, uh, like for an example, here 0 is the last digit. Again I am deleting this term. Again 1 by 30 will be deleted because 0 is the last term. This will be deleted. Also I will delete because here 0 is the place at the second places. So whenever you are finding any in denominator, because of course in the denominator there are just natural numbers. So if you find 0 at any place, just remove. And now I am asking, can you tell me, so what is the remaining series after deletions? You are getting, so this one, like 1 plus 1 by 2 plus 1 by 9 and 1 by 11, 1 by 19 and 1 by 21, because I have removed those terms which contain 0 at any places in the denominator. So on. Here I am writing 1 by 99. Then again I will remove 1 by 100, 101. So next term will be 1 by 111 in this way. So any guess? So I have removed all those terms which denominator contains 0. And I'm asking, can you tell me whether this series is the sum of this series is finite or infinite? So this is the very, you can say that there are very interesting things, because we have just proved that the sum of this series is infinity, right? And I am just removing those terms which denominator contains 0, right? I have just deleted few terms from like those terms. So any guess? So most you can say, like sometimes I ask these questions and I found response, because here no student is sitting here, so I have to somehow I have to tell my experience with these questions, what a student tell me maximum. So a student tell me generally ki sir, the sum of this series will be infinite. And if I ask you, okay, why you are thinking that sum of this series is infinite, so many times they say that since if you don't delete those terms, like say for an example 1 by 10 will be here, 1 by 20 will be here, and so on, here 1 by 100, so that sum is infinite. So you are just deleting few terms, that's why that is not going to impact. So infinite minus something, you are removing those terms whose sum will be finite. They are the student logic in most of the cases. So yeah, so here I am going to prove that that is not a things. So some of this series will be, you can say, finite. That's the very interesting. So because this sum is infinite, like sum of the original series, this is infinity, and I am saying that sum of this series is finite, and when I say ki okay, sum is infinite, then what is the value? For an example, in this case, in second series, sum is finite and this value is 2. So, okay, for this series, number 4, like what will be the sum? If I am saying that is finite, so is there any fixed value? Can I say ki okay, this value, when sum of this series is finite value? That you can't prove. Like no one know that what is the exact value, but that is for sure that this sum of the series will be finite. What is finite, I don't know, but this value is always less than 90. This is a very interesting. His sum will be less than 90, and so let us prove. Let us check ki how this sum will. How you can prove that? First of all, that after deleting those terms, and okay, so if even if you just assume, or if you just trust me, or you believe me for a moment कि okay, what I am saying is correct, then can you see the beauty of these questions? Like whether I am not interested whether the sum is 90 or 100 or something like that. That is not my concern. My concern is that if this series is, sum of this series is finite, that means what? So this series is say infinite. Of course, we have proved these things. And say you are removing those terms. And what are those terms which you are removing? Say like removing terms, sum of removing terms. Say like 1 by 10, 1 by 20. These terms we are removing, right? 1 by 90, 1 by 100, 1 by 101. So if you add this series with these things, then this is just a original series. That means what? So say if this value is finite, just for the time being assume finite, right? So that means 90, which is a finite number, plus this finite. So sum of two finite can't be equal to infinite. So what I am trying to say, if say if I am going to prove, of course this is correct, so that the sum is finite, so this must be infinite, so that infinite plus finite is infinite. So my point is ki the terms you are deleting, first of all there are infinite terms and their sum is also infinite. So although you are finding ki okay, here, although you are finding ki okay, but there is a only few terms you are deleting. You are thinking because you are just looking for the first few terms. If you go ahead, you will find that these terms will occur frequently. So yeah, so of course this is not correct. This sum will be infinite, and it will be easily clear if I prove that okay, so sum is sum of this series is less than 90. And I must tell you, this question has been asked in, I think, a few years back at ISI's ISI entrance test. So yeah, so how I can prove these things? This is a very interesting. Okay, so what will you do? You have to again grouping. You have to group few terms like I did for the question number 3. So here again I will uh, so here again I will just prove these things by taking few terms in a group. Okay, so okay, so okay, so can you tell me 1 plus 1 by 2 plus 1 by 9? So of course this value is less than so if I am taking that 1 is the largest value here, so this is less than 1 plus 1 plus 1, so this is less than 9, right? And again 1 by 11 to 1 by 19. So how many terms are there? 9 terms. And so I have grouping in this way, right? Okay, that first I have considered 9 terms, and this one is the largest, so that's why I am taking that this value is less than 9. So this value is you can check that 1 by 10 is like all numbers are less than 1 by 11, so this will be less than so there are 9 terms again, so I can write 9 by 10. Okay, and similarly, like say for the rest of the things, and you can check like that how many terms will be there. So 1 by 11 to 1 by 99. For an example, here there is a 9 terms. Again, there is a here 9 terms. So 1 by 21 to 29. So here I am writing for an example 1 by 21. So later 1 by 29. So again, all the terms is less than 9 by 10. And if you go to say here say 1 by 91 plus 1 by 92. So again all this term is less than, because I have considering all this in the denominator, all this 2-digit number is starting from 11. So all this 2-digit number is less than 1 by 10, and there are total 81 terms. Why? Because you can just check that there is the 9 terms, and you can go in this way, so you will get the 9 into 9. So I am not writing in all these things. I will just write here that if you go from 1 by 11 to 1 by 99, here, and then you will find that there are total 9 square terms, because every block consider 9 and there are total. So this is basically all the sum is less than 1 by 10 into 9 square, right? Because all term is less than 1 by 10 and total there are 9 square terms. So that's why I have written 9 square by 10. And okay, so similarly now I will go to the those terms whose denominator contain 3-digit terms like 1 by 111 to 1 by 999. So 1 by 111 to 1 by 999. So you will find that of course every term is less than 100, okay, and this is basically uh, all there are total how many terms? So 9q. So this is nothing but you can say that 9q by 10 square. Okay, so there are total 729 terms, you can easily count. Okay, so yeah, because from here of course we are just counting those terms which denominator doesn't contain 0 and every terms is less than 1 by 100. So these many terms will be there. So you are finding here patterns, right? That and you have to just go and so on. So and now you have to add. So how many terms are so okay? So now you have to just add, and you will find that you are getting this series. The series I gave you to find the sum. So this is, so if I say this series is S, okay. So if you add, so again here I have just done a blocking in such a way, like for an example, I have considered a blocking with in such a way, like in which denominator has just 1 digit, and second part is that denominator had 2 digit. Here denominator has all these 3 digit. Again I will go to the those terms which denominator have 4 digit, and this will of course cover all S, okay, and this is less than what, 9 plus, it's visible, okay, 9 plus 9 square by 10. Okay, so I'm just writing this side. This series I am writing here. If you add, and then you will find that S. So I am adding now. I am adding. Okay. So S is basically less than 9 plus 9 square by 10 plus 9q by 10 square 100, 94 by 10q, and of course you have to go to infinite because there are terms, there are infinite terms, and every time you are doing blocking which containing finite terms, so number of blocks should be infinite, right? And you can just check that this is the again a pattern, and this is called geometric series, because if you multiply by 9 by 10 in every term, so you are getting next term. So this is called the common ratio, and I have I think used these things ki, if R is the common ratio, this is called the first term. So this is the formula. So I am going to use this thing. So in this case, first term is 9 and common ratio is 9 by 10. So if you just calculate, and you will find that this value is 90, because 9 into 10, 10 minus 1. So yeah, so this is the things. So here, these questions, you can say like, you can appreciate the beauty of these questions, because uh, in this series, number of like we are just taken the sum of reciprocal of natural numbers, and we prove that this is infinite. We are removing only those terms whose denominator contains 0, and we find that this series is going to be finite, gives finite value. That means what you have removed, what you are deleting, that is the major part. That is going to, or you can say that constitutes some infinity. And that's why uh, what left remaining becomes a small compared to what you are deleting. And in the first moment, it's very difficult to realize. If you just seeing the first few terms of the series, it's very hard to realize. So these are very interesting questions. And now I will tell you to look for this problem. So instead of 0, so here in this series, I have removing those terms. Now what I am telling you that instead of these terms which contain 0, remove those terms who contain 7 or 5. So for an examples, if I am asking you that okay, so first of all write 1 plus 1 by 2 plus say 1 by 6 plus 1 by 7 plus 1 by 8 to 1 by 16 plus 1 by 17 and in this way, like 1 by 26 plus 1 by 27 and so on. So now what I'm telling you, to delete these terms like 1 by 7, 1 by 17, 1 by 27 and then 1 by 37, so on. So wherever you are finding 7 at any places, at any, then you have to delete. And now tell me what will be the sum. The sum will be finite or infinite. So this is assignment for you, and you will check that again this series will give you finite value, and instead of 7, if you delete those terms which contain 5 at different places, so 1 by 5, 1 by 15, 1 by 25 and so on, again you will get finite. So again you can generalize ki okay, what are those digit. So okay, so I'm giving you a simple assignment. So work for 7, that what will be the sum of this series, and I'm telling you that sum will be finite. Now the important point is ki, can you tell me ki less than what? So for example, in the this questions, this is less than 90. Okay, I'm not saying ki what is the exact value, and it's not always possible to tell the limiting value, or you can say that forget about these standard kind of terms limiting. So for an example, in class 11th, generally a student first time introduced about sequence and series problems, but they always, in the syllabus, they just read about only very basic type of series like arithmetic series, geometric series, harmonic series, and there are some also this kind of series like arithmetic, geometric series, telescopic series, uh, and few more series like but yeah, very limited. But you can say ki why only those say 6 7 types of series, even you will get questions from only those kind of series. And you can check that in your class 11 syllabus you always say ki what is the value of the series in maximum in most of the cases. But once you go, like it's not always you can say like it's not necessary that for an example in this case we are saying that sum is finite, but we are not saying ki what is the exact value of this series. We are saying ki if sum is finite and less than some value, okay. And in more sophisticated term these are called this series is converging, okay. But forget about this word. So yeah, so the assignment is that you have to now check at your home that what will be the sum. Okay, now come to the next. We are continuing in this way. Like so, here I have given I think four series. So we will proceed in this way. Okay. So say I told you that one plus half plus 1 by 3 plus, we have already checked that this sum is going to infinity. Can you tell me like about what do you think whether so whether this series this is called basically so this is called Euler series. And in if you want to write in general terms, so you can think in that way कि 1 plus 1 by 2 to the power s 1 upon 3 to the power s, and so here I am taking s a positive integer. So for example, if you take s equal to 1, you will get this series. For s equal to 2, you will get this series. For s equal to 3, you will get this series. For s equal to 4, you will get this series. Okay. So this type of series which I have written here. So like in the I think in the last class I have told about I think Euler. This series, like Euler has like this series has fascinated Euler. Euler was very curious about this series, and this basically known as Euler series. But I am just writing just what is the value of these things, and I am discussing why this is important. Like a series problem always is an important problem. I think even before Euler, uh, people have think about this series, particularly this one. I think this is called Bessel series. But at that time, they are not aware that what is the sum of the series. So Euler has proved that Euler means I am talking about some around mid 18th century. Okay, so this value is pi square by 6. This value is pi to the power 4 by 90. And interesting thing is that if you take s even integer, for an example here, if you take s equal to 2 like this one, s equal to 4 this one, then Euler has always given a very nice formula and and you can always tell ki okay, what is the value of this series if S is even integer, and that is always related to, you will always find this pi terms in all these things for any S. So if even if I say what is the value if S is 50, there is a formula. Like formula is not, but you can derive. He had derived in very standard way, and I think anyone has class 12 kind of mathematics, they can easily understood. Not a difficult kind of things. You just need some kind of polynomial, some kind of trigonometry kind of things. Interesting part is like what is the sum of this series, like if S is odd and 3 is the, like okay, so if you are taking S equal to 1, first of all I am telling you that if you take S equal greater than 1, for example 2, 3, 4, for this part I think 40-50 years back, even Euler was not able to solve that what is the sum of this series, and I think I don't remember correctly, but this is the irrational number, and okay, so very like just 30-40 years back, someone has proved that uh, the sum of this series, particularly for S equal to 3, is uh, irrational, and something 1 point something. Okay, but important part is that if you take S equal to 5, for an example, say if I am asking okay, this one, okay, and of course the value will be finite, and you can always say that what is the approximate kind of things, but no one has proved that whether this series will, sum of this series goes to rational or irrational. This is the interesting things, that this problem has been started so long, but still uh, like no one has proved that this series either goes to rational or irrational. So yeah, so now come to this part that uh, for an example, say if I ask ki, if I am giving you a say geometric series, and I am asking ki, so geometric series is what? Geometric series is like so please let me know if there is any question. Okay, so these are the terms of uh, geometric progressions. Okay, and questions are, sir, why don't we take creating a GP then 1 by 3 plus 1 by 9 then take prime? What will you? Okay, so can you tell me, Soumya Bansali, what do you want to say? I think you are telling about that like you are. I think you are talking about in some context. So can you tell me, like, hello? So yeah, so you can ask me like what you want to say. Uh, okay, so can you tell me like uh, if I am telling you ki take a geometric progression, take a geometric series. So how many primes? How many how many maximum number of primes any geometric series will contain? Any guess? Can you prove that they are okay? So if I'm asking कि क्या आप ऐसा कोई ज्योमेट्रिक सीरीज दे सकते हो, बता सकते हो जो 3 प्राइम कंटेन किए हुए हो? Can you write any geometric progressions, geometric series, okay? Or forget about series. Like I'm asking, can you write a geometric sequence which contain 3 primes? So how can you prove whether this is possible or not? I'm telling you this is not possible. You can't uh, write geometric sequence which contains 3 primes number. How can you proceed? There can't be geometric sequence which contains 3 prime number. Okay, so before that, I'm asking another questions. So I'm asking you, okay, write an arithmetic sequence. Think about arithmetic sequence which have infinite terms. And you know what is arithmetic sequence? Like uh, the common difference is same. Like so. So you have to just like take a arithmetic sequence. Arithmetic sequence means like common difference. Common difference means any, like if you take considering 2 consecutive terms, their difference will be same. So 1 plus d, a plus d, a plus 2d, a plus 3d, and so on. Okay. So if I'm asking key, you have to write arithmetic sequence which contain infinite terms. So can you tell me how many primes, how many maximum primes any infinite arithmetic sequence will contain? How many arithmetic, how many maximal number of primes number? So here I am telling you to, you have to think about uh, a infinite sequence of arithmetic, infinite arithmetic sequence, like arithmetic progressions which have infinite terms. And my question is ki, how many maximal number of primes will contain? So here in the previous question I am saying that in any geometric sequence you will not get more than 3 prime number. I am going to prove these things. But here, so there is a very famous result in number theory called Dirichlet theorem that say, you know, like what is the general terms of arithmetic progressions? Like if I am asking you what is the Tn means like you can say last term, or you can also say general terms. And it's not very difficult to write the general term. This is basically a plus n minus 1 into d, right? And so here a is called basically first term, d is common difference. So if these two terms are given, you can always write the, and I'm not going, this is the basics things you can easily prove. And so you can check that this is the linear function. So in class 10 you know equations of line at y equal to mx plus c, right? So here if a and d is given, so this is the linear part. So I am in the general terms, I am writing that say always if you, whenever you find that general term of any sequence is linear expressions, then you can always think that of course that is the arithmetic sequence. So general term, what you have get for arithmetic progressions, a plus, and I am writing here not n minus 1, say a plus kb, right? Here k is variable, I have just written n minus 1 equal to k. And I am saying, and what is the Dirichlet theorem, that of course this is the very standard theorem in number theory, and very standard result, but of course proof is a standard, but like you need up like I'm just like writing the just the result. Okay, so if a and b has GCD 1, GCD matlab, this is the, you know, like GCD, like the common factor is 1, then you will always get, like in this sequence you will always find infinite number of primes. Okay, and this is the Dirichlet theorem key. In this form, if a and b are relative prime, and why I'm writing a and b relative prime, because if a and b will be not a relative prime, say d will be the common factors, then of course d will divide all the numbers. So like you, okay, so in more general term you can say that either uh, what can I say, if a and b is equal to 1, there will be infinite number of arithmetic, there will be infinite number of primes in this sequence. And if you say a and b is GCD of a and b equal to d, then all will be composite, right? D will be divide these things. So what is the final things? Final things is that in any arithmetic sequence with these conditions, ki a and b are relative primes, will always have infinite number of primes. So that sequence, infinite number sequence, always contain infinite number of primes. So I'm giving you examples. Maybe you are aware that sometimes people say, ki, okay, prove that there are infinite numbers of prime of the form 4k plus 1 4k plus 1 or 4k minus 1 or 6k plus say 5. I am saying कि not only if you, I am saying अगर मैं आपको बोल रहा हूँ कि अगर कोई ऑर्थोमेटिक सीक्वेंस है जिसका फॉर्म ए है, सो इस सीक्वेंस अगर आप लिखते हो k का 1, सो एक टर्म्स k 2, इफ यू राइट अ इनफाइनाइट नंबर ऑफ टर्म्स, then you will always get infinite number of primes. So this is the general statement. So you will always get infinite number of primes, but जब हम लोग प्रॉपर मैं नंबर थ्योरी स्टार्ट करूंगा तो कुछ चीजों को मैं बेसिक्स लाइक नंबर थ्योरी से प्रूफ करूंगा, लाइक जस्ट यूजिंग बेसिक लॉजिक, लाइक जैसे मैंने लास्ट क्लास में प्रूफ किया था कि हाउ कैन यू प्रूव दैट देयर आर इनफाइनाइटली नंबर ऑफ प्राइम्स जस्ट यूजिंग यूक्लिड एल्गोरिथम. सो हियर you can prove basics result like 4k minus 1 and 6k minus 1. You can use just by contradiction, like what I have done in the last class in case while proving that there are infinite number of primes. But yes, this is the general state. You must keep in this mind so that and this is a very fascinating things कि यार अगर मैं कोई भी अर्थमेटिक सीक्वेंस लिख रहा हूं, ठीक है, सो like what you are getting that if a plus kb and अगर a and b जो है gcd d है, सो चाहे तो आपको एटमोस्ट 1 प्राइम मिल रहा है या इनफाइनाइट नंबर ऑफ प्राइम्स मिल रहा है. एटमोस्ट 1 किस लिए? क्योंकि अगर इफ अगर फर्स्ट टर्म आपका इन लाइक ये है, हो सकता है कि अगर फर्स्ट ही कंपोजिट हो, क्योंकि अगर ए एंड बी के बीच जीसीडी डी है एंड डी से यू कैन से व्हाट कैन आई से लाइक डी विल डिवाइड ऑल दिस टर्म, सो देन सारे टर्म्स जो है वो कंपोजिट हो जाएंगे बिकॉज ए एंड बी के बीच जीसीडी डी है, सो यू कैन ऑलवेज टेक डी कॉमन. ओके, सो सारे वो कंपोजिट हो जाएंगे. और अगर कांस्टेंट आप एपी ले लिए लाइक 3 तो वो हमारा इंटरेस्ट नहीं है. आई एम नॉट इंटरेस्टेड इन कांस्टेंट एपी. अदरवाइज विद दिस कंडीशन यू विल ऑलवेज गेट infinite number of primes in that sequence. Okay, so let us come to our previous questions कि एक ज्योमेट्रिक सीक्वेंस में मैं बोल रहा हूं कि 3 से ज्यादा प्राइम्स नहीं हो सकता है. So let us prove these things and you have to just use a simple things like जीपी के टर्म्स कैसे होते हैं, लाइक सो लाइक इफ यू से that let us prove by contradictions कि एक ज्योमेट्रिक सीक्वेंस में 3 प्राइम है. सो लेट अस स्टार्ट विथ हियर एंड लेट P Q R are 3 primes. Okay, so what will be the form of this? Okay, so say P is basically, because you know like what is the general terms of this is the general term, right? क्योंकि any GP has terms in these forms. So if you write, so of course for any GP A and R will be fixed. A is basically called first term, R is common ratio. So say I'm writing it this way. Then oh, so you have to just do little bit calculations and can you okay. So from the first equations you are getting P by A uh, P by A equal to R to the power N1 minus 1. P by B equal to R to the power N2 minus 1. And P by C equal to R to the power. Why I have written N1, N2, N3? Because if I am saying that P Q R उस sequence में नहीं है तो उनके position कहीं भी हो सकते हैं. They are not necessary कि वो consecutive ही हो. Okay. So that's why उनकी positions जो है वो that will depend on this n. So in first case I have considered that okay, if you put n equal to n1, the terms will be p, and say for n equal to nt there is q and r. So okay, now again I have to just I just want to do relations between p, q and r. No, this is not p, this is q and r. This is q. No, sorry, this is the confusion because here I have taken r comma ratio. So let us take this one, not PQR but PQR1. Otherwise there will be confusion because R I have already taken comma ratio. So PQR1 are the 3 primes, and this is the, no, I am not writing a correct equation, sorry. Okay, let me start here. So let, instead of PQ I am writing it that X, Y, Z are 3 primes, or 3 primes in geometric progressions which first term is A and comma ratio is R. Okay, fine. So let us consider, for an example, consider that X is in this form. X is basically A into R to the power N1 minus 1. Y is A into R to the power N2 minus 1. Z is A into R to the power N3 minus 1. So okay, so what I am now trying to do ki, in the last I will do some kind of contradictions. So doing contradiction I have to find some relation between x, y and z, and that's why I have to do something here. I have to do some calculations here. So okay, so that's the good thing ki A is everywhere. So I will write that x by A, okay, x by A equal to R to the power n1 minus 1, y by A, okay, y by A equal to, what can I say, R to the power n2 minus 1, and z by A equal to R to the power n3 minus 1. Okay, and can you help me? How can I proceed further? So again you can say that okay, so do one things ki what can I say? Okay. X by A. Hmm. So if I divide X by Y, okay, so let us divide here. If I'm dividing here X by Y, so R to the power say N1 minus N2, okay, and Y by Z is basically R to the power N2 minus N3. So, okay, mm, and you just hmm, what can I say? Like how I can hmm, there are three primes. These are the forms. I have to somehow put conditions like so contradictions that if x, y, z are primes, okay, so hmm, if I take that these are the consecutive like consecutive number, say x, y, z are, for an example, of course this is not, I think this should not be a case. If x, y, z are say like these are the primes and consecutive, so in that case y square equal to xz. Of course this is not possible because if x, y, z are prime, then x and z is prime, so these are two distinct primes, and y is also primes. So right hand side this expression had two distinct prime factor, but in the LHS only one prime factor with exponent 2. So this will be not possible if xyz are prime, because if xyz are primes, three consecutive terms of a GP, this will happen, and this is not possible because right hand side there are two distinct prime factor, but LHS is only one distinct prime factor, so this is not possible. But this is not our question. I am saying that at there will be not be three primes at any places, so that's why I have introduced n1 here. So this is the general things. So somehow I have to find, okay, hmm, hmm, I think we have to do something here. Okay, so let us no, x y z is so hmm, Okay, so I think I'm missing some point here. So I will discuss this part in the hopefully in the next class. Something is there, some tricky part is here. I think we have to just do contradictions, but I'm not directly finding here. So okay, so I will come to this part in the next class. There is some basic things here I have to do, and showing I will show the contradictions. So anyway, so but the question is same that uh, there are there can't be three primes in geometric progressions. Yeah, this is the things. Okay, so I will definitely come back to these questions, but okay, so let us proceed for the next questions. And so I'm telling you why uh, I have given these questions, because in arithmetic sequence I have just given a statement in the name of Dirichlet theorem that you will always get infinite number of primes if you just carrying these things, that GCD of A and B is equal to 1. And okay, and in the last here, okay, so it's fine. So I think this is the very interesting things for this series. For this series, like 1 plus 2 to the power any, I am taking any in general S, okay, so on this, and so you can say like here is the summation. I'm going to write this form into different form, uh, and so here this is the just a sum of the series. Can you write okay, so just think about any power, like say any general in this series, there is a term say k to the power s. So k is any number, it might be prime or composite, yes or no. And there is a very nice theorem, maybe you heard about that fundamental theorem of arithmetic, that you can always write any composite number as a product of primes. Okay, so for an example, 24. So you write that this is the, you can write 2q into 3. So here 2 prime factor. So if there is any say any k, if k is any number like any general terms, so you can always write as the product of primes, say p1 to the power say r1, p to the power r2. This is the very fundamental and very important, you can say, if we will use uh, like this basics results in like many questions, like you yes or no, and you have like I believe that आप बहुत स्टार्टिंग से ही इस रिजल्ट को आप यूज कर रहे होगे. So say not say p to the power s, r to the power s. So that means what? Can you write these things in this way? Like say for an example, 1 plus say 2 to the power s, say 2 to the power s whole square, and so on. 1 plus, I'm just using this basic result. You can always write any number in this form, like this is called fundamental theorem of arithmetics. So this, and why I am only writing like this, so base is always prime, 5s, 5 to the power 2s, because you know like prime is the fundamental block. You can say things like that you can always write any number, or you can always see, you can always visualize, or you can always represent any number in terms of primes. So because of these theorems, So you can write in this way, because say for example this term, so 1 by 2s, take all 1 from the other bracket and so on so on. These are all the, and this is the say 1 plus 1 by p to the power s, p to the power 2s, and so on. For example, if you want to write 1 by 6s here, so how you will get 1 by 6x? So say 1 by 2s and multiply 1 by 3s, you will get 6x. So in that way, you will always get, you can always write this thing in this form. This is one of the very nice, and you can say simple and very elegant result. Okay, so here this is the sum, but in you are represented this sum as a in the product form. And so yeah, and what is these things? This is the, you can see like this is again a geometric series. Yes or no? First term is 1, and here comma ratio is 1 by 2s. In this case, first term is 1, comma ratio is 3s. So by using this formula, you can write that a upon 1 minus r, these things. Yeah, a upon 1 minus r, and similarly 1 upon 1 minus, and so on, 1 upon 1 minus 1 to the power, say ps, okay, or okay. And yeah, so 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 uh, I have written here, this is the summation, like sum form, and just I have converted this series into, you can say like these are the products. So you, I think if you are not aware, this is the sign of sigma, sum. So if I am writing, say for an example, say something like that, for example n, I'm writing n equal to 1, say k. What does this symbol meaning? That you have to add up to k terms. So this is the your function, or you can say that you have to put here, so 1 plus 2 plus, in this way up to k. For example, I am writing what this thing means, what here, this is these things, 1 by s, 2 by s, and again I am just introducing one another notations. So say for an example, I'm not aware whether you have faced these notations or no. So if whenever you find this thing, so this is for an example, say like n, and someone is saying that n equal to 1 to s, that means you have to put the value in this function and just take a multiplications, like 1, if you 2 here 2, so 1 into 2 into 3 into, so up to s. Okay, and say for an example, I'm writing here say these things like n to the power, for example, s, and here I'm writing n equal to 1 to say, okay, so say like say I'm writing here k, okay, here is s. So what you will get, say 1 to the power k, here you have to put 2, so yes or no, in this way. So you have to just put in this function and then just multiply. Here this is the summation things, that you have to just put the value and add these things. So if you want to use this, because these are the product, right? So if you use this notation, so what will you get? Because here this is the multiplication, so 1 upon 1 minus 1. What is varying? So this 2, 3, 5, 7. So these are the primes. So 1 upon, you can say p to the power minus s, because 2 to the power minus s, this is 3, or here p is what? P is basically prime. Okay, prime. So this is called Euler product formula. And okay, so in the next slide I am writing, this is very important. And okay, so what I have just shown in the last slide, that 1 upon 1 plus this series and so on, you can write in this form, 1 upon 1 minus, yes, 1 upon p to the power s, where p is prime. And this is called very interesting Euler product formula. Okay, so now you can ask me that why this is important, like why this is interesting. Okay, so you can just look on this formula and you will find that so when I have given this series in the when I have started from here, like and if I am varying, for an example, H2, 3, 4, and this is the general things. I never talked about the primes, yes or no? So I have just started with the any series of this form, and then we prove that this is related to or you can write in terms of in some functions of you can say primes. So that is the beauty. So here we are going to do something. So for an example, say for an example, just put s equal to 1. Put s equal to 1. And what you are getting? If you put s equal to 1, then series will be 1 plus 2 plus 1 by 3 and so on, plus 1 by n and so on. And what you are getting in the right hand side? This is 1 minus 1 by p, right? Where here p is prime. And if you just open this thing, so you will get 1 upon, so you are starting with prime 2, so one this thing 1 upon 1 minus 1 by 3. Yes or no here, because prime is prime. I am just writing this 1 into 1 minus 5. Sorry. This is 1 upon 1 minus 1 by 5, right? And so on. And say, and in the I have discussed that what is the sum of this series? Infinity. So from here you can prove. So for an example, like if this series has I have already proved that the sum of this LHS, or you can say that this series has sum is infinite. That means right the sum, this part also of infinite. तो यहां से क्या आप प्रूफ कर सकते हो कि प्राइम्स इनफाइनाइट है? लास्ट क्लास में हमने यूक्लिड का मेथड यूज करके हमने बताया थे कि प्राइम्स इनफाइनाइट है, राइट? यहां से भी आप बता सकते हो। कैसे? अगर आपको ये रिजल्ट पता है जो हम लोग अभी डिराइव किए, तो एक आपका एक डिफरेंट मेथड है प्रूफ करने का। कैसे? सो अगर आप बोलते हो लेट अस अस्यूम कि नो प्राइम तो फाइनाइट है, फॉर एन एग्जांपल लेट अस प्रूव बाय कॉन्ट्राडिक्शंस कि नहीं प्राइम फाइनाइट है, तो इसका मतलब क्या हो गया कि अगर आप बोल रहे हो कि प्राइम फाइनाइट है, मान लो फॉर एन एग्जांपल, तो ये जो राइट हैंड साइड जो आपको टर्म्स दिख रहे हैं, ये फाइनाइट नंबर ऑफ टर्म्स हो जाएंगे, क्योंकि ये मल्टीप्लीकेशंस कहां तक जाएगा? p तक जा रहा है। तो अगर p फाइनाइट है मतलब ये जो जो आपको ये टर्म्स दिख रहे हैं वो क्या हो जाएंगे, आपके फाइनाइट टर्म्स हो जाएंगे। तो क्या ऐसा हो सकता है क्या कि, और ऑफ कोर्स सारे टर्म्स आपके फाइनाइट है, पी जो है आपका नंबर ऑफ प्राइम्स फाइनाइट है, तो ये राइट हैंड साइड क्या बता देगा कि दीज आर द जस्ट अ प्रोडक्ट ऑफ फाइनाइट नंबर्स। और अगर आपके नंबर्स जिनका प्रोडक्ट्स ले रहे हो वो फाइनाइट है, तो उसके प्रोडक्ट कैसे इनफाइनाइट होगा? आर यू गेटिंग माई पॉइंट? क्योंकि LHS गिविंग यू वैल्यू इनफाइनाइट, वी हैव ऑलरेडी प्रूव्ड, तो RHS को भी इनफाइनाइट देना चाहिए, देना होगा। एंड इफ यू कंसिडर कि प्राइम्स फाइनाइट है, देन एक कॉन्ट्राडिक्ट कर जाएगा, क्योंकि अगर प्राइम फाइनाइट है तो ये जो आपको ब्लॉक्स दिख रहे हैं नंबर्स का, ये सिर्फ फाइनाइट नंबर ऑफ ब्लॉक्स हो जाएंगे। हर एक ब्लॉक फाइनाइट है, क्योंकि ऑफ कोर्स दीज आर जस्ट अ फाइनाइट नंबर। So this is another proof, right, to show that there are infinite number of primes. And you can say like this is also easy, but this is the first analytic proofs to showing that there are infinite number of primes. And okay, so let us come to, so this is the again you can say that this is the beauty, right? Like this is the very interesting thing, that in this way by writing Euler product formula, and in this formula में हम लोग क्या क्या यूज किए हैं, मेन चीज क्या था, 2 पॉइंट्स था इंपॉर्टेंट। एक तो ये था कि हमने हर एक नंबर्स को जो हमने प्राइम्स के प्रोडक्ट में लिखा, जिसको मैं बोल रहा हूँ फंडामेंटल थ्योरम ऑफ अर्थमेटिक, यस और नो। एंड वी हैव रियलाइज दैट दिस ऑल टर्म्स इज गुड, क्योंकि आप किसी भी टर्म्स के लिए चेक कर सकते हो, कोई भी अगर से नंबर आप लोगे तो उसके प्राइम फैक्टर होगा। तो फॉर एन एग्जांपल, अगर से n टू द पावर s में 3 का है, तो इसमें से 3 का कोई कुछ आएगा, या 3 का अगर 2s है तो इसमें से कुछ आएगा। आर यू गेटिंग माई पॉइंट? सो all this term will be covered by these things, and it's not difficult to prove, but you must check this part, okay, and then you have to use the geometric progressions, the sum of infinite series, and you will come to this part, and this is the very interesting kind of things, okay। and for s equal to 1 के लिए हमने देखे कि LHS तो इनफाइनाइट है, तो RHS को इनफाइनाइट होना चाहिए। तो अगर प्राइम फाइनाइट हो जाएगा तो ये फाइनाइट नंबर है, आप नंबर्स का प्रोडक्ट लिखोगे जो कभी इनफाइनाइट देगा नहीं। सो सो दिस इज द थिंग्स, एंड सो ओके। एंड लास्ट क्लास में मैंने यहाँ पर हम लोग डिस्कस कर रहे थे कि प्राइम्स के लिए क्या किसी ने उसके फॉर्म देने के लिए ट्राई किया होगा? ऑफ कोर्स, तो बहुत पहले लोगों ने, फॉर एन एग्जांपल फॉर्मेट ने लाइक एक नंबर सजेस्ट किए थे 2 into 2 द यस और नो, एंड सो उन्होंने स्टार्टिंग्स में ऐसे बोल दिया था कि ये जो फंक्शंस है fn, लाइक सो, क्योंकि मैंने लास्ट क्लास में भी आपको बोला था कि f0 जब आप लोगे तो ये 3 आएगा, यस और नो। ये आपके प्राइम देंगे, 1 डालोगे तो 5, f2 डालोगे तो 17, यस और नो। f3 डालोगे तो कितना आ जाएगा, 8 2 to the power 8 plus 1, 2 4 8 16 32 257 to this is 257 and f4, so f4 will be 2 to the power 4, मतलब 16, 2 to the power 16 plus 1, and I'm not going to write that, but Fermat had checked all these 5 things, and उनको लगा कि चूंकि ये सारे प्राइम दे रहा है, ये भी आपका प्राइम नंबर आएगा, ओके। आई डोंट नो व्हाट इज दिस वैल्यू। सो उन्होंने बोला कि ओके, सो उनको एक इंटरेस्टिंग लगा कि ये तो सारे प्राइम्स दे रहा है, तो बाकी के भी नंबर्स प्राइम्स आएंगे, लेकिन जस्ट उसके आई थिंक 1 या 2 साल के बाद ही गॉस ने बोला कि F5 जो है वो 6641 से डिवाइड होता है। सो तो आपके माइंड में आ रहा होगा कि यार ये व्हाई ही हैज नॉट चेक फॉर F5, उनको इतना जल्दीबाजी क्यों था, व्हाई ही वाज सो इन हरी की फॉर्मेट जैसे मैथमेटिशियन जो like kind of why like this is kind of blunder, like you have say something and just after 1 year someone has proved। आपको लगता है कि आज के टाइम में ऐसे कोई कैलकुलेशन रिलेटेड चीज करता, बट आई एम टेलिंग यू व्हाई। सो व्हेन यू आर टॉकिंग अबाउट फॉर्मेट, सो समहाउ वी आर टॉकिंग अबाउट जस्ट 300 years back and there was no computational power। so like अभी ऐसा नहीं था कि आपके पास फोन, हर किसी के फोन में मुझे लगता है कि 10 डिजिट का कैलकुलेटर तो आपके फोन में ही होता है कि यू कैन जस्ट थिंक अबाउट दिस नंबर F5। जैसे नाउ वी आर इन द 20th century एंड अभी जो है काइंड ऑफ कंप्यूटेशनल पावर इतना ज्यादा है। जस्ट थिंक अबाउट कि आप फॉर्मेट के एरा से हो एंड आपके पास एक नंबर आया F5 जिसकी वैल्यू है 2 to the power this one and this is I think 32। can you tell me how many digits are in this number? how can you find that एक नंबर्स में कितने डिजिट्स हो सकते हैं? अगर मैं आपको एक नंबर दिया 8 7 6 4 2 5, आप तुरंत काउंट करके बोल दोगे कि सर इसमें 1 2 3 4 5 6 7 टोटल नंबर ऑफ डिजिट 7 है। बट आई एम गिविंग यू दिस नंबर, आई एम आस्किंग यू कि हाउ मेनी डिजिट्स आर देयर, हाउ मेनी डिजिट्स आर देयर। सो आई एम नाउ गिविंग यू जस्ट अ सिंपल फॉर्मूला बट यू कैन इजिली प्रूव दिस थिंग्स। तो क्योंकि आप देखो, अगर आपको बेसिक्स लॉग पता होगा, क्योंकि लॉग जो है आपको पता है कि लाइक 10 बेस ए अगर आप लेते हो तो कोई भी नंबर अगर ए जो है 1 से 10 के बीच में लो तो इसके वैल्यू जो है, क्योंकि लॉग 10 बेस 10। ओके, सो लेट अस राइट इन दिस वे। so this is basically equal to 0, right? 10 base 10 is 1 log 10 base 10 square। so I'm just using this thing। so what I'm trying to say कि अगर आप कोई नंबर लो से log 10 base x और x का वैल्यू अगर आप 1 से 10 के बीच में लोगे तो वैल्यू जो होगा आपको ऑलवेज 1 आएगा, लेस देन 1 आएगा। कब? जब आपका x का वैल्यू कहां से कहां तक होगा, 10 के बीच में होगा तो, राइट। एंड इसकी वैल्यू लाइक 1 से 2 के बीच में आएगा, लाइक 2 से कम बट 1 से ज्यादा। ओके, 1 से 2 के बीच में। कब? जब आप x की वैल्यू जो है 10 से 100 ले रहे हो, राइट, क्योंकि 10 बेस 10 पर 1 है और इस पर 2 है। सो व्हाट आई एम ट्राइंग टू से कि अगर आपको नंबर ऑफ डिजिट चाहिए तो इसमें आप log 10 में ले लो और उसमें आप 1 ऐड कर दो। सो नंबर ऑफ डिजिट्स जो होगा, नंबर ऑफ डिजिट्स, ठीक है, इनसे कोई नंबर x है, ओके, एक जहां इंटीजर में लिया हूं, ये कितना हो जाएगा, log x बेस 10 और मैं ग्रेटेस्ट इंटीजर फंक्शन लिया हूं +1, क्योंकि log जो है उसका वैल्यू है और रियल नंबर आता है। सो आप यू हैव टू, बिकॉज डिजिट यू आर काउंटिंग डिजिट 10 मिनट्स। ओके, सो इन दिस केस इफ यू जस्ट काउंट द नंबर ऑफ डिजिट्स तो इसकी वैल्यू कितनी आ जाएगी, number of digits in log, sorry, number of digits in what, number of digits in 2 to the power 32 plus 1 is basically log base 10 2 to the power 32 plus 1. Yes or no? Plus 1. And this one is plus 1. Okay. So this one is not going to impact many things. So you can just write 32 into log 2 base 10. I'm just ignoring 1 because even if you are just adding 1, that is not going to change the digit unless this 1 is at the last. For example 99, तो अगर 99 लिए और उसमें 1 ऐड कर रहे हो देन उसके डिजिट 2 से 3 जा रहे हैं, लेकिन इन बिटवीन अगर आप 10 से 99 ले रहे हो देन देयर इज नो एनी पॉइंट. ओके, सो आई थिंक log 2 की वैल्यू 0.3 होता है, राइट? एंड सो दिस इज 32 दिया 9.6. So box of 9.6 मतलब 9. So this is the 10 digits number. So फॉर्मेट ने जो हम अभी लग रहा है कि यार उन्होंने क्यों नहीं आगे का चेक किया, उन्होंने ऐसे बोल दिया कि नहीं ये ऑलवेज प्राइम देगा, एंड इवन द जस्ट नेक्स्ट ईयर गॉस हैज प्रूफ कि नो दिस इज कंपोजिट, बिकॉज उस जमाने में उस टाइम में ये जो नंबर आपको दिख रहा है 10 डिजिट नंबर था. तो आज आपके पैकेट में फोन है और 10 डिजिट के साथ काम करना आसान है, बट इन दैट टाइम 10 डिजिट वाज अ ह्यूज नंबर. और इंटरेस्टिंग चीज ये हुआ कि फॉर n इक्वल टू 5 टू इफ यू टेक, सो fn क्या मिला आपको? प्राइम मिला. कहां से कहां तक? इन जो है 0 से 4 तक ऑल आर प्राइम्स. और कंपोजिट है, ये अब तक प्रूफ हुआ है कि अगर आप n 5 से लेते हो, 5 से बड़ा एंड 31 तक, तो ये ऑलवेज कंपोजिट आएगा. आज तक लोगों को नहीं पता है, दिस द ओपन प्रॉब्लम्स, कि n इक्वल टू 32 पर क्या हो रहा है, या इवन 32 और 32 से ज्यादा, फॉरगेट अबाउट 32 से ज्यादा, इवन व्हाट F32 is, whether this is prime or composite. तो अगेन आप बोलोगे कि सोचो जो फॉर्मेट के लिए उनके टाइम में लगभग 300 साल से भी पहले जो डिफिकल्टी था, जो प्रॉब्लम्स था, आज आपके लिए एग्जैक्टली वही डिफिकल्टी है जब इफ यू आर टेकिंग N32. क्यों? क्योंकि जो एग्जिस्टिंग आपके पास कंप्यूटेशनल पावर है, जो आपके पास इवन यू कैन से सुपर कंप्यूटर है, अब हमारे पास तो घर पर जो मशीन है वो तो ठीक है, उसमें भी बहुत, बट इवन इफ यू यूज द सुपर कंप्यूटर, यस और नो, एंड ओके, सो अभी मैंने आपको एक बताया कि नंबर ऑफ डिजिट्स कितने होते हैं. जस्ट आप घर पर सेम चीज, सेम फॉर्मूला यूज करके करना कि इसमें कितने डिजिट आएंगे व्हेन यू इफ यू आर पुटिंग N32. ओके, एंड फॉर दैट बिग नंबर्स को चेक करना कि वो प्राइम है कंपोजिट इज द ह्यूज टास्क. मैंने लाइक इवन आज के टाइम में वी डोंट हैव मैंने दैट काइंड ऑफ कंप्यूटेशनल जो आपको बता पाएगा कि वो प्राइम है या कंपोजिट है. सो स्टिल दिस इज ओपन प्रॉब्लम्स, एंड लोगों को लगता है कि ओके इट्स फाइन, अप टू 4 तो प्राइम था, 31 तक तो कंपोजिट था. तो कुछ लोग को लगता है कि क्या ये जो अगर मैं फॉर्मेट सीक्वेंस लूं तो क्या उसमें इनफाइनाइट प्राइम्स आएंगे क्या? बट लोगों को बिलीव है, मैंने सी दिस इज अगेन ओपन प्रॉब्लम, बट मेनी पीपल्स बिलीव कि नो, लाइक अगेन दिस इज यू कैन से कंजेक्चर्स, दैट उनको नहीं लगता है कि इसमें इस सीक्वेंस में देयर विल बी इनफाइनाइट प्राइम्स. वन एक मैं काफी इंटरेस्टिंग चीज इससे बता रहा हूं कि जो फॉर्मेट नंबर है Fn, इसको आप ऐसे लिख सकते हो. सो दिस इज द यू कैन से ब्यूटीफुल रिकरेंस रिलेशंस, यस और नो. एंड आप चेक कर सकते हो कि आपके जो फॉर्मेट नंबर्स आ रहे हैं वो इस तरह से अपने प्रीवियस टर्म पर रिलेटेड है, और यहाँ पर मैं उसके एक्सपोनेंशियल फॉर्म ना लेकर उसके रेफरेंस फॉर्म में लिया हूँ. एंड यू कैन चेक फॉर एन एग्जांपल. सोचो आपको चेक करना है कि फॉर एन एग्जांपल से आप चेक करना चाहते हैं कि F4 क्या आएगा. तो F4 अकॉर्डिंग टू दिस okay, so ये आपका assignment रहेगा. You can easily prove these things, not a difficult task. I can give you hint. So, but just verify this thing. If you put n equal to 4, then you will get F0, F1, F2, F3, right? Plus what? 2. So check what is F0. F0, I think you have checked, na? F0 is 3. So F0 is 3. You just multiply here. 3 into 5. Not just check up to not 4, just take up to F3. So 3 into 5 into 17 plus 2. कितना आएगा? So basically F3 is 3, 5, 17 plus 2. तो 15 into 17. So 15, 225, 30. 225, 30 कितना? 255 plus 2. Yes, 257. This is your F3. Okay. So yeah, and you can prove these things. And now I am just going to next part. This is not difficult. You know what is the sequence of what is Fn. Fn is basically your 2 to the power n plus 1. So just take this minus 2 equal to this. Fn minus 2. Fn minus 2 means 2 to the power plus 1 minus 2 minus 1. So 2 to the power, this you can write n minus 1 whole square minus, so a square minus b square. So 2 to the power 2 n minus 1 plus 1 into 2 to the power 2 into n minus 1 minus 1. And this is what? ये आपका f n minus 1 है. Again फिर इसको ब्रेक कर दो, है ना, तो आपको f n minus 2 है, उसको रिकर्सिवली वो चला जाएगा. Now I am just telling you, we have 5 minutes. I want to prove one results here. That's very important. कि आप अगर कोई भी okay, so this is the important result कि अगर आप कोई भी फॉर्मेट नंबर ले रहे हो, मतलब पेयर ऑफ फॉर्मेट नंबर्स ले रहे हो, वो ऑलवेज रिलेटिव प्राइम्स होगा. सो व्हाट आई एम ट्राइंग टू से, व्हाट इज क्वेश्चंस? क्वेश्चंस इज कि Fm and Fn, and say for example I am saying that where n is say greater than m. Okay, so GCD of this is always equal to 1. This is a very nice and important results. एंड इसको कैसे आप प्रूफ करोगे एंड क्यों इंपॉर्टेंट है वो मैं पहले बता देना चाहता हूं कि अगर मैं इसको प्रूफ कर दिया तो मैं आपको एक और मेथड दे दूंगा कि देयर आर इनफाइनाइटली मेनी प्राइम्स. सो दैट्स व्हाई आई वांटेड टू प्रूव दिस रिजल्ट्स. ओके, एंड ओके, सो कैन आई गिव दिस क्वेश्चन टू असाइनमेंट बिकॉज ओके, बट लेट अस प्रूव. सो सपोज करो कि एज्यूम करो कि ओके डी जो है हमारा जीसीडी है, जीसीडी ऑफ Fm Fn. ओके, लेट अस कंसीडर दैट डी इज द जीसीडी एंड मान लो कि डी जो है ग्रेटर देन 1 है. ओके, तो अभी हमने देखा है कि चूंकि n बड़ा है तो हम Fn को कैसे लिखते हैं. अभी हमने लिखा था ना कि Fn minus 1, Fn minus 2, कहीं Fm होगा, राइट, Fm minus 1 and so on, F2, F1, F0, राइट, क्योंकि है ना हमने उस रेफरेंस फॉर्म में लिखा था. सो वी ऑल्सो नो व्हाट, सॉरी, दिस प्लस 2, राइट. सो अगर D जो है ओके, सो यहां से आप क्या देख रहे हो कि अगर Fm जो है Fn को डिवाइड करेगा तो रिमाइंडर 2 देगा, यस और नो, क्योंकि दिस इज द मल्टीपल ऑफ Fm प्लस 2. ओके, सो Fm जो है किसको डिवाइड कर रहा है, मतलब यू कैन राइट दैट Fn इज बेसिकली कांग्रेस टू 2 मॉडुलो Fm. दिस इज द जस्ट वन काइंड ऑफ रिप्रेजेंटेशंस लाइक दैट, ये बताता है कि अगर FM से इसको डिवाइड करे तो रिमाइंडर 2 आएगा। ओके, एंड सो यानी इसको और सिंपल वे में मैं अगर आपको बोलूं तो आप लिख सकते हो कि FM जो है किसको डिवाइड करेगा, FN माइनस 2 को। इसको हटा दो, ये अगर आप, इफ यू आर नॉट कंफर्टेबल विद दिस थिंग, ऑफ कोर्स बिकॉज maybe we have not discussed Congress, so forget about this. This is the divide sign that FM जो है इसको डिवाइड कर रहा है, और मैंने assume किया हूं कि D जो है इनका कॉमन GCD है। D जो है इसको भी डिवाइड कर रहा है, इसको भी डिवाइड कर रहा है। तो चूंकि D जो है FM को डिवाइड कर रहा है, मान लो D इसको डिवाइड कर रहा है, इसका मतलब D जो है इसको भी डिवाइड करेगा, FN माइनस 2 को भी, और D पहले से ही FN को डिवाइड कर रहा है, तो अगर D इसको डिवाइड कर रहा है तो इसका मतलब D 2 को भी डिवाइड करेगा। और 2 को डिवाइड करने वाला नंबर क्या हो सकता है, आइदर 1 हो सकता है या 2 हो सकता है। बट आप सोचो, ये जो आपका FN था, FN का फॉर्म है 2 इंटू टू द पावर n माइनस प्लस 1, एक ये ऑड नंबर है, राइट। सारे फॉर्मेट नंबर ऑड नंबर्स है, तो कोई भी अगर नंबर ऑड है तो उसका डिवीजर कभी इवन नहीं होगा। तो अगर D जो है FM को डिवाइड कर रहा है ना, D हमने लिखे कि GCD है, तो D मस्ट बी ऑड होना चाहिए। तो कौन सा ऑड नंबर है जो 2 को डिवाइड करेगा, तो 1। तो यहां से आपका प्रूफ हो गया कि ये जो D आपने GCD लिया था वो 1 होगा। एंड व्हाई दिस इज इंपॉर्टेंट, सो दिस इज द बेसिक थिंग, जस्ट वेरी फंडामेंटल थिंग्स। अब सोचो यहां से, कैन यू प्रूव दैट कि देयर आर इनफाइनाइटली मेनी प्राइम्स? यस। कैसे? कि हमें जो फॉर्मेट नंबर्स है, ये जो फॉर्मेट नंबर है ये तो इनफाइनाइट नंबर है। दिस इज द जस्ट इफ यू जस्ट पुट n 1 2 to infinite, you will get an infinite numbers, yes or no? And any pairs are relative primes. That means what? अगर say f1 f2 and so on, f10 and so on, ये कोई भी हम पेयर ले रहे हैं वो आपका रिलेटिव प्राइम्स है। दैट मीन्स व्हाट? दैट मीन्स कि अगर कोई भी, फॉर एन एग्जांपल f2 और एनीथिंग f10, इसमें कोई भी, चूंकि अगर ये आपका जो भी इसका प्राइम फैक्टर है, अगर ये खुद प्राइम है तो ठीक है, कंपोजिट है तो इसका कोई ना कोई प्राइम फैक्टर होगा, से प्राइम फैक्टर उसका P1 है। अब ये P1 इसमें से कहीं दूसरे में नहीं होगा, तो सारा नंबर जो है आपको एटलीस्ट 1 डिफरेंट प्राइम्स दे रहा है, और देयर आर इनफाइनाइट फॉर्मेट नंबर्स। इनफाइनाइट आपके पास नंबर है, फॉर्मूला है आपके पास, और कोई भी में कॉमन प्राइम्स नहीं है, क्योंकि हमने प्रूव किया कि दे आर रिलेटिव प्राइम्स। सो हर एक फॉर्मेट नंबर जो है एटलीस्ट आपको एक प्राइम नंबर दे रहा है जो किसी के साथ मैच नहीं है, एंड दैट प्रूफ दैट देयर आर इनफाइनाइटली प्राइम्स। तो आज के क्लास लेकर हमने ये दिखाया कि हम 3 ऐसे प्रूफ्स देखे जो बताता है कि देयर आर इनफाइनाइटली मेनी प्राइम्स, और तीनों ही प्रूफ्स जो है वो इजी हैं, है ना, लाइक जस्ट बेसिक ही है। सो या दिस इज द थिंग। सो आज के लिए इतना ही, मिलते हैं नेक्स्ट क्लास में। ओके।